Welcome back, dear students. This is the final video of this session, NMR spectroscopy. In the last video, we are going to discuss about the application of NMR spectroscopy in elucidating the structure of organic molecules. Some simple molecules are discussing here. How can we determine the structure of the compound from the NMR spectroscopy? First is acetone, also known as propanone. Acetone, we know that the formula is CH3COCH3. Then how many lines are you expecting? Yes, of course. We know that here there are 6 hydrogen, 3 here and 3 here. All these 6 hydrogens are chemically equivalent. Look at here CH3 is bonded to CO. This CH3 is also bonded to CO. That is, these 2 CH3 groups are in chemically identical position. Therefore, all the 6 hydrogens are chemically equivalent. So we expect only one single sharp line for the 6 hydrogen. We get a singlet here. And this is about delta about 2.4 something like that. This is the line for DMS, tetramethylsilane. That is our standard reference compound in chemical shift method of determining spectra of NMR spectroscopy. So okay, that is the first compound. It's very simple. Our next compound is ethanol. That is CH3 CH2 OH. Here, how many different types of hydrogens are there? Yes, you can see here. This three hydrogen is one type. This 2 hydrogen is another type, and this hydrogen is the third type. There are 3 types of chemically equivalent hydrogens are there. So we expect 3 lines, 1, 2, 3. Of course, 3 line is obtained. This is the line for TMS. That is at delta equal to 0. Okay. And this is a line for CH3 group. This is a line for CH3 group at a delta of about 1.2. And this line split into 3 due to the spin splitting of these 2 hydrogen, nearby hydrogen. We know that we have already studied that due to spin splitting, an equivalent hydrogen is split into n plus 1, where n is the number of neighboring hydrogen. Here neighboring hydrogen is 2, therefore it is split into 3. In the ratio, according to Pascal triangle, when n is 2, it is 1 is to 2 is to 1. That we have already discussed with here, 1 is to 2 is to 1. Okay. And this is actually this is the line for the CH2 group. That is about 2.6 delta. Actually, this line split into a quartet by this CH3 group. Okay, but these 2 hydrogens are spin splitting with both this hydrogen and this 3 CH3 group. But if the reaction or the spectra is carried in acidic medium, this OH will replace, then only the splitting by CH3 group is obtained. But if you are taking this is spectra of acidic ethanol, I think. But in pure ethanol case, this CH2 group is split into quartet by these 3 hydrogen, and each line of the quartet split into doublet by this 1 hydrogen. That we have already studied an equation, Na plus 1 into Nx plus 1. Like, that is Na plus 1 here, 3 plus 1, 4 into Nx is 2 here. Sorry, 1 here, 1 plus 1, 2. That is 2 into 4, 8 lines. Actually, we get 8 lines like this. Okay. That is the case of this CH2 group. Okay, this is split by both this CH3 group and this OH group. And this is in a higher delta value because this CH2 bonded to electronegative oxygen. Therefore, it is less shielded. Therefore, delta become higher. This CH3 group is more shielded. Delta is small. And this is a line for hydrogen. It is split into a quartet, split into a triplet by the CH2 group. Okay, this is higher delta value, approximately 4, approximately 3.8 something value is obtained for a delta value. It's split into a triplet. Actually, line should be like this, like 1:2, 2:1. That is the spectra of ethanol. We get 3 lines, like 3. This is 3 hydrogen triplets. This is 2 hydrogen multiplets. And this is 1 hydrogen triplet. Okay, each at different delta values. That is ethanol. And our last compound, that is propanol, CH3, CH2, CHO. CH3, CH2, CHO. This is for the TMS reference line 0 delta 0. And here also we can see that there are 3 types of hydrogen. This is CH3, one type of hydrogen, CH2, another type of hydrogen, this CH, third type of hydrogen. So we get 3 lines, 1, 2, 3. 3 lines are obtained. But this is a line for CH3. This is highly shielded CH3 group because no electronegative. You understand one thing. If a hydrogen is near to an electronegative atom, it will be more shielded, low delta value. Okay, if there is no electronegative atoms nearby the hydrogen, it will be highly shielded, is low delta value. For the CH3 group, there is no electronegative atom, it is highly shielded, low delta value. But the CH3 group is nearby this CH2 group, 2 hydrogen near. Therefore, according to n+1 rule, it's split into 3. Therefore, we get a triplet here, 1, 2, 3 type. In the ratio 1:2:1 according to Pascal triangle 1. And this CH2 is first nearby this 3 hydrogen and 1 hydrogen here. First this 3 hydrogen split the line of CH2, that is about the 2.4 delta, split into quartet. And each line of the quartet is again split into doublet by this hydrogen. Therefore we get a multiplet. Like that, or total of 8 lines will be here. Okay, that is the case for CH2 group. And for this CHO, actually this CHO is like this. Okay, and this CH line will be very high delta value, about 9.8 delta. Okay, this value we get a triplet due to the splitting by these 2 hydrogen. We get a triplet here. A triple like this. Okay, the very high value of delta for this hydrogen is, it is very less shielded, it is de-shielded due to this pi electron. It is called the paramagnetic de-shielding. Paramagnetic de-shielding effect. That is not in your syllabus to study. Actually, there is an effect like that. That is, it is less shielded. Paramagnetic effect. It is less shielded, or here the spin magnetic moment due to the pi electron is aligned with the applied magnetic field. So very low value of field strength is needed. Therefore, its delta value will be higher. Okay, and that is the case for propanol. We get 3 lines. One line for CS3, it is split into 3 by CS2 group, and another for CS2 group, it is split into an octet. That is doublet of quartet, quartet by CS3, doublet by CS. So quartet of doublet by this CS2, and a triplet by CS proton by the splitting due to the CS2 group. Okay, that's all about NMR spectroscopy. I think you might have understand the topic, and for further understanding and for further studies, please read the textbook very carefully and take notes of the topic very well. And I am stopping here. NMR spectroscopy, this chapter is over. Spectroscopy, there will be an examination about this topic, spectroscopy, in the coming days. I will announce you later. Okay, study well. Thank you.